The propaganda, the disinformation that has been routinely dispensed by Monsanto and its allies has had a major effect. That's why the mainstream media now is awash in stories of how safe GMOs are and how utterly out to lunch those of us with concerns are. That's based on disinformation and people not even understanding the facts. They're on this market contrary to sound science and illegally. As I speak, every genetically engineered food on the market in the United States today was put there illegally, and it is still there illegally.
Is the dream of helping the most vulnerable sectors of our society, the children and the lactating mothers who are not reached by the current interventions in place. We never say that golden rice is the silver bullet. We're saying that golden rice can be and will be an added tool in our toolbox to complement the existing interventions, which are you eat a diverse diet, breastfeeding, fortification. While all these interventions are working, cannot be denied that still sectors of the society are not reached by these interventions. And considering that we eat a lot of rice, we will be complementing these current efforts. Our plant breeders now are better equipped with tools that can help develop better varieties. These tools were not available during the times of my professors because science is evolving. New tools are coming in, and it is our responsibility to use these tools in our breeding work. With today's advance in science, you can even direct where your gene will go. This was not available during my time, but it's available now. So we harness available tools to develop better products. These are my takeaway messages. Number one, golden rice can be a complementary tool to existing intervention to alleviate vitamin A deficiency. Number two, it will only be released if it has received all approvals and it matches the farmer expectations in terms of yield and consumer preference. And third, any decision should be made on science, not based on fear.
Jet bridge today. If you are claiming a pink tag carry-on bag upon arrival, we ask that you step to the side of the jet bridge to allow other customers to claim while you wait to claim your carry-on baggage. If this is your final destination, check bags may be claimed.
Now I'm looking at my questions and I'm wondering they may not be...
Don't worry about it.
Okay,
It's all right.
Yes, so I've been involved in a project for a little more than 10 years developing, trying to understand the genetic basis of flood tolerance. Many farmers in South and Southeast Asia grow rice in flood-prone zones. And this is problematic because the floods come sporadically and they're increasing in intensity and duration, likely because of the effects of climate change. And so these are very poor farmers. Generally, they are growing only enough food to feed themselves and their family. And so a big focus of genetic improvement and agricultural improvement is to develop seeds that will be useful for farmers in less developed countries. My collaborators at the International Rice Research Institute developed several varieties of rice that are tolerant of flooding, so they can withstand floods for 2 weeks, and most rice varieties will die within 3 days. It's been very important for farmers. They're harvesting 3 to 5-fold more rice after floods. So this is a genetic technology called marker-assisted breeding, and I think it's been very important for farmers in those areas. I think there's concerns about so-called GMOs, and I think part of the problem is the terminology in the conversation, because there is no such thing as, we can't sort of categorize all GMOs together. There are many different types of genetically improved crops. Everything we eat has been genetically improved using some kind of artificial method. In fact, it's often called artificial selection. And so I think what's really important is to advance the goals of sustainable agriculture using whatever technology happens to be appropriate. And usually it's going to be a combination of technologies. Yeah, there is a lot of misinformation, and it's really difficult for consumers. Maybe they're not familiar with the scientific consensus about the use of genetic technologies. So every major scientific organization in the world has concluded that the process of genetic engineering is no more risky than other types of conventional breeding technologies. And so the focus really is to look at what are the results. Can we enhance food security? Can we enhance sustainable agriculture? And so I think the messaging is, there's a lot of messaging for marketing, and I understand that these are large companies, whether they're an organic company or another, they want to sell their product, but I think it becomes very problematic when misinformation is passed out that are scaring people. And of course, we've seen this with many other types of scientific issues. We've seen it with climate change. So, and it's very kind of tribal. So many Republicans will push back, reject the science on climate change because that's what their tribe has decided to do. And then on the left, we see this rejections of vaccines because of misinformation from movie stars. And that's creating epidemics in some very wealthy communities and very, very frightened people. So they're very scared. They really believe there is a huge risk if they're vaccinated that their child will have some disease. And there's no scientific evidence for that. And of course, it's harmful if the child is not vaccinated. They could be infected with a deadly disease. And so that's also very tribal. Certain communities, whole communities, will have this idea that vaccines should not be used. And it's the same, in my mind, the exact same situation with plant genetics. And it's more difficult with plant genetics and farming because something less than 1% of people in the United States are farmers, even fewer are biologists. And so there's been a lot of fear promoted on various websites, and I think consumers don't know that they can go to the National Academy of Sciences or the American Association for the Advancement of Science and really look at the scientific consensus. And I think that is really an important aspect of my job and other scientists to really bridge that gap between to help consumers know where to go for accurate information, and to reduce the fear and try to use appropriate technologies to advance sustainable agriculture and food security.
I think many see the organic movement as being a reaction to the industrialization of agriculture, and I think that's certainly true, although I think that the organic movement really came from so many different threads. It's really hard to divine what its ultimate origin is, but certainly consumers who were looking for organics and growers who started identifying themselves as organic growers inherently saw some sort of critique of industrial agriculture that they were supposed to improve upon. This is what makes organics what it is today, is it's the way it's regulated. that organics, unlike natural, or now there's a new word, clean or real or even local, organic has a very specific set of meanings that have been developed and codified over time. And all the institutions that help support those meanings have developed over time, and it's unlike almost any other kind of thing you could ascribe to a type of food. Okay, so at one point there was so much dynamism in the organic market that a lot of folks wanted to have the federal government involved. In part because different states had different laws, different certifiers had different laws, and some of these people wanted to ship internationally, and different countries had different standards and rules, or had none at all. So they wanted to kind of regularize it. And so, but a lot of growers didn't agree with it. A lot of the people in the organic community didn't agree with it, but it was the kind of the big players that went ahead and pushed for the federal involvement. And at first the federal government was, they wanted nothing to do with it, and in part they didn't want to disparage the rest of the food supply. But at some point they realized that this was a dynamic and growing market, and really the fastest growing market in foods, and that they really had to support their clientele, and so they agreed to have a federal standard. So Congress passed the law in 1990 that just had the basic stipulation that we'll have a national law over organics, and then it took over 10 years, if I recall, for the federal government to come up with a specific set of rules of what organic would be at the national level. And when they first came out with the rules, they came up with like a list of over 70 inputs and practices that organic growers completely shunned. 3 of them were the use of irradiation, the allowability of GMOs in organics, and sewage sludge. The folks behind GMOs originally imagined that genetically modified organisms would be a sustainable replacement for pesticides. That's how they still market it. They say, well, we think we're part of the solution, not part of the problem, right? That's how they position themselves, that they're helping to solve the problem. So I think there were some that were kind of taken aback that the organic community so roundly rejected GMOs, but it depends if you want to give it a more cynical read or not. Hundreds of thousands of comments to the Federal Register, and eventually the federal government reversed on that and came up with a standard that was closer to what the organic community was actually practicing. The regulators realized that if consumers were so opposed to this, that it wasn't going to have meaning and it wasn't going to accomplish what they set out to accomplish, which is to kind of create this other niche market. That, it had to have meaning, and even like the big producers that were behind the federal government recognized that if it's not a meaningful difference with conventional agriculture, it's going to blow out our market. I mean, people read these fights as like having it organic be completely undermined, and it's again less ideal than the agroecological standards that a lot of growers aspire to, but it's not completely meaningless, or else people wouldn't buy it. And the big producers that were, kind of leading the pack knew that. It allowed growers who were interested to get into organics for various reasons to do so. And then it also, the effect that no one expected is that growers who might have been abiding by those standards but didn't want to go through that hassle, or had great relationship with their customers, if customers didn't need certification, just dropped out of organics. And so organic has come to be more like, I don't want to say middle of the road, but it's more, it's not a standard that assures purity, a standard that assures like some sort of minimum that you meet these standards. And so as more and more conventional producers got involved in organics, some of the original organic growers felt left out or lost out. They lost out on some of their markets, and some folks wanted to go beyond organic, and then that created all these contradictions, because then these guys that were had moved into organics because for reasons, because of the market or whatever, were told, well, they didn't feel like they were welcome, and that was very confusing for them, because they felt that, well, you guys wanted us to convert to organics, and now, now you don't really want us to convert because it's hurting your markets. And so when you certify organic, what you're doing is you're saying that I agree to abide by this set of standards, and in return for that standard, in return for abiding by that standard, I expect to be rewarded in the marketplace because people will know that I'm an organic farmer and they'll pay for it. My concern is just with the contradiction of a label as a way of moving a broader swath of farming and food production to a better way.
People the world over, this is one of the few psychological universals that's been identified, have a tendency to imagine that there are underlying hidden forces that make the world the way that it is, the way that it appears. And we call these essences. And that they're sort of intrinsic inside objects that somehow seems magically gives rise to those objects. And that's what makes a dog different from a cat. Somehow it's these invisible essences that people perceive to exist. And more recently, there's a new placeholder that people are that seems to capture people's intuitions about essences, which is our genes. Our genes are not the same thing as essences, but they share quite a few properties with essences. So one, we think of our genes as having that they're immutable, that you can't avoid a particular outcome to the extent that you have a gene associated with that outcome. Also, we think of genes as natural, and we think of essences as natural, and so that we think that's the way they are meant to be. And when people talk about what's natural, they often fall for what we call the naturalistic fallacy, and they equate what is natural with good. Also, that we think of genes like essences as dividing up the world into categories. So we talk about essences as, say, it carves nature at its joints. It's what distinguishes a rabbit from a kangaroo. They can kind of look sort of similar, but we know they're different deep down. The way they're different deep down is that they're different in their genes, and we think that they're different in their essences. Well, I think essences are relevant to GMO foods in a couple of these what we call essentialist biases that people have. One is that we think of genes as being natural, and so the genes that exist in products that grow in the natural world, we think of as their default natural state, and the way they're meant to be, and that if you've now modified the genome to change those products, many people would view this as deeply unnatural then. And if it's unnatural, then it must be bad and threatening in some way. And so some of the kinds of arguments that people bring that are consistent with that, and I should emphasize, I think there's lots of other kinds of arguments people can make against GMO that don't involve this idea about essences, and I find many of these arguments quite compelling. Not that I'm going to say that GMO products are good in every way, but I do think that this one concern that people have with them is that it's unnatural, reflecting on people's tendency to view essences as underlying food. One response that people have then is that, well, this is unnatural. A GMO tomato is not the same as a tomato in the wild, and this is unnatural. And because it's unnatural, it's bothersome in some ways. One way that it's bothersome is that it seems that humans are doing things that humans aren't meant to, that messing with the natural world, I think many people would say, messing with God's creations. So actually that's what some activists say GMO stands for God move over. Humans are taking charge, and I think that's a bothersome idea to many. And another bothersome idea with GMO is where the genes come from. And there are two kinds of genetic modifications that occur. One are called cisgenic modifications, and that's when, say, if you're talking with tomatoes, you get a gene from a related species, another kind of tomato, another varietal, and bring that into the tomato that you are modifying its genome. People generally aren't so bothered by that because that's not crossing our perceived boundaries of essences. It's still a tomato gene. This is just a new tomato gene in this tomato. People aren't so bothered by that. Where they get more bothered is if the gene comes from a different species. For instance, a tomato once was grown that had a gene from an Arctic flounder, which is a fish, which was chosen because this gene helps the fish's blood not freeze in the Arctic waters, thinking maybe this would have the same benefit with tomatoes, so that tomatoes wouldn't freeze on the field. Turns out it didn't work out. However, it's this idea is quite bothersome to many people that this now is somehow a cross of these essences, a tomato essence and a fish essence together sounds like an abomination. One survey found that about half of people imagine this tomato is going to taste fishy. It would be a fishy tasting tomato because it has essence of fish in it. One aspect I think that is not appreciated that well is that our genes are shared with many other organisms. We share about 20% of our genes with yeast. We share 90-something% of our genes with mice. Like our genes aren't only part of humans, sort of reflecting our long evolution across time, that genes that serve certain functions are preserved in our genome from far distant species. So we actually do have we share genes with tomatoes, we share genes with Arctic flounder, that we already do, and it's because these genes are not essences of Arctic flounder, essences of human. A gene makes a protein that does something in our body, and we share a lot of those same proteins across the natural world. So research finds that if you look at GMO opponents, and there's many GMO opponents, and there's many reasons that people are opposed to GMO products, but about 70% of opponents appear to have opposition with GMOs that's consistent with what we would call an absolute moral violation. That means people view it as inherently wrong, and regardless of costs and benefits actually aren't weighed much in these decisions. And you can see evidence of this because you can tell people, well, imagine that this product would have this other benefit. Would that change how you feel? And if people's responses are unaffected by any sort of costs or benefits that you suggest, that suggests that it's not a moral decision based on weighing costs and benefits. It's a moral decision based somewhat on viewing this as just inherently wrong. And so surveys find it's about 70% of GMO opponents have that as their core feeling of opposition to GMO products is tied up with this absolute moral value. Science is scary, I think, in many ways, because it's proceeding really quickly is one thing, and especially with genomics. Genomics has, the technological improvements have been far outpacing the technological improvements in the computer. So for instance, we talked before about Moore's Law. It was something that a lot of people would hear about, the idea that computer chips are doubling in their capacity every 2 years, that a computer would double in the number of transistors that it could have. The genomic advances have been going at a rate several times that. And so the first human genome was sequenced in 2003. And that first genome cost several billions of dollars, took many, actually millions of person years worth of work to solve it. There's so many people working on this from around the world. But now it's under $1,000 and you can get this done in a couple of days. So it's really rapidly changed. And same with the technologies to edit things, like CRISPR was just discovered a few years ago, and it's already being applied in so many different ways. And so I think this is one part of science that's a little fearful, is that it happens really rapidly.
There aren't any significant food crops for direct human consumption that are legal to plant in a GMO form anywhere, with very, very few exceptions. It's now legal to plant a GMO BT eggplant in Bangladesh. It's legal to plant GMO white maize in the Republic of South Africa. But that's about it. Food crops for direct human consumption, like wheat or rice or potato, haven't been commercialized in a GMO form in more than just 1 or 2 countries around the world. They haven't been commercialized in the United States. When it gets to animal feed crops like maize or soybeans, those are more widely commercialized. And when it comes to industrial crops like cotton, there are still more frequent adaptations and adoptions of those crops. But even for an industrial crop like cotton, if you go to the continent of Africa, there's only one country in all of tropical Africa that has yet made it legal for farmers to plant GMO cotton. That's Burkina Faso. So the uptake of this technology has been heavily constrained, particularly for food crops, but even in some cases for industrial crops. In the United States and in Canada and in other industrial countries, the technology has been developed mostly by private companies. And in those countries, the United States and Canada, for example, the technology can be patented and can be sold as a proprietary technology. In developing countries, it's completely different. The technology is often being developed by public sector institutions, not by private companies. And in nearly all of the developing world, it's not legal to make a patent claim on a plant. So in developing countries, it's easy to imagine that the technology is going to be dominated by private companies because that's what happens in the United States. But that's an inappropriate assumption for developing countries where the technology is often available free of charge. In rich countries, we've used the ability to make patent claims as one incentive for private companies to develop new applications of biotechnology. Historically, there hasn't been a lot of private investment in the development of new seeds because seeds copy themselves. It's very hard for companies to recover their investment. One exception has always been hybrid crops, like hybrid maize, where the benefits of crop improvement can't be captured by replanting the seed. You have to go back to the hybrid seed company and buy a new year's supply of hybrid seeds. And so there have been large private investments in hybrid maize, for example, and that's one reason hybrid maize yields have gone up so rapidly. When it comes to GMO crops, what the advocates for patent protection say is that, well, if we allow companies to patent a GMO variety of an openly pollinated, non-hybrid crop, well, it'll bring in as much private investment as hybridization did, and that's going to be good for innovation. If you look at what is holding back biotechnology in Africa, it's a set of very strict regulations that make it illegal for farmers to plant GMO crops. Now, where did those regulations come from? They came from European NGOs like Greenpeace and Friends of the Earth, which have campaigned in Africa to convince African governments to adopt the same very strict regulatory systems that are found in Europe. Those systems in Europe haven't allowed the commercialization of any GMO crops, and so when African countries embrace this same European-style regulatory system, they don't approve any GMO crops either. So in a sense, the modern European influence on Africa isn't the traditional colonial relationship. It's, to some extent, a neo-colonial relationship where Europeans are no longer imposing direct political control, but European-based NGOs are ventriloquizing onto African governments European-style regulatory systems. Well, right now, on the shelf, there are varieties of cotton and maize that are genetically engineered to protect against insects without the need for insecticide sprays. So African governments could approve BT cotton or BT maize and grow those crops with reduced insect damage without any need to purchase and spray toxic insecticides. That would be good for the income of farmers. It would be good for the yield of the crops. It would be good for the protection of the environment. And these are technologies that are already available. But as I've said, in tropical Africa, the only country to approve any GMO crops at all is Burkina Faso, and they've approved BT cotton, but no one else so far has followed suit. I wrote a book about these problems in 2008. I was discouraged at the time that Burkina Faso was the only country to have approved BT cotton. I'm a little more discouraged now that in the 7 years that have passed, no country has followed Burkina Faso, and BT cotton is not legal to grow in anywhere else in tropical Africa. BT cotton in India was denied approval by the government for a number of years because of active resistance by campaigners against GMO crops. BT cotton had been a success in China since 1997, and farmers in India wanted BT cotton because they knew it would allow them to protect against cotton bollworm pests without having to spray so many insecticides. But the government didn't approve BT cotton because of campaigns against GMOs. It finally was approved only after Indian farmers got their hands on GMO seeds through their own initiative. These are so-called stealth seeds that some companies developed surreptitiously. And farmers love these seeds because they protected against insect pests. After an insect infestation, some farmers that were planting these BT seeds were outed because their fields were perfectly fine while everyone else's fields were destroyed by the insects. So the secret was out. Everybody knew that BT cotton was being planted already. The government tried to pull it back and force farmers to destroy those fields and stop planting the seeds, but the farmers at that point stood up and said, absolutely not, we need this technology. And so the government relented and approved BT cotton, at least in some parts of India. And that was 2002, and after the government's approval of BT cotton, the technology spread very, very rapidly. And now more than 90% of the cotton grown in India is BT cotton. It's been phenomenally successful. It's boosted farmer income. It's protected farmers from exposure to toxic insecticide sprays. It's protected the environment from toxic insecticide sprays. But it remains controversial. We can't make any strong claims yet, one way or the other, because the technology isn't being used by more than just a handful, a relative handful of farmers in the developing world. In all of sub-Saharan Africa, in the tropical countries of sub-Saharan Africa, the technology is illegal to use. So we don't except Burkina Faso with cotton. So we don't have the evidence that's needed to make a reliable claim about the contribution it can make to food security. Campaigners against GMOs like to say, oh, listen, it hasn't solved the world's food problems. It hasn't improved the lives of farmers. Well, of course it hasn't. It's not legal to use these seeds yet in most developing countries. It's frustrating to me that we're not giving farmers the choice of whether or not to try these technologies. In every country where they have been given permission to plant GMO seeds, farmers have done so. They've done so eagerly and they've done so successfully. And adoption rates have been extremely high. That's true for yellow corn in the Philippines. It's true for cotton in both China and India. It's true for cotton in Burkina Faso. It's true for soybeans, of course, throughout Latin America. Wherever the technology has been made legal to plant, farmers have planted it eagerly and with technical and commercial success. But in most cases, it's not yet legal, and so we don't know. We don't have good information on how the technology could perform in the countries that need it the most, particularly in tropical Africa. Well, if you look at either the United States or Canada or European countries. These are countries where farmers are already prosperous, where consumers are already well fed. In fact, most of them are overfed. These are countries where large corporations play a prominent role in food and farming systems, where farms are industrial scale, deeply engaged in international markets and international finance. In these countries, it's possible to imagine the role of corporations as maybe going too far, the drive for ever more productive agricultural practices as perhaps unnecessary. I understand the anxieties that citizens in rich countries have about the next technology in farming. But it's a mistake for citizens in rich countries to then project those anxieties into developing countries where you often can't find any multinational corporations, where technology has barely been improved at all, where farmers are not yet productive, where their yields are only 1/10 as high as in the United States or Europe, where their income is only $1.25 a day, and where a third of them are chronically undernourished instead of overfed. It's just a mistake to project the concerns that citizens in rich countries have about their environment onto environments in the developing world that are so completely different.
Right. I like that.
It's really important for all of us to focus on the goals of sustainable agriculture, which is to feed the poor and malnourished, try to use less toxic inputs, conserve land and water, enhance soil fertility. There's a number of very, very important issues that are increasingly important as the climate changes. I think a focus on how a seed was developed, what genetic technique was used is just a big distraction from the need to really get serious about food and farming and the environment.